doing this talk on, maybe it's a kind of a badly named talk now that I think about it, because it doesn't say physics, it doesn't say courseware, it doesn't say educational, it doesn't say open source. It's just the CUPS project, past, present, future. So let me move into what that's all about. So, well, but before I do, I have a disclaimer. This is about some really old software, and so and it's a little bit of an adventure story figuring out the historical content. I'm hoping that I got the history of it right. Maybe if I put this video online, there'll be corrections, but I'm trying to do the best I can with the information that I've got. So I'm an electrical engineer and a programmer. I do C++ and embedded systems, and I have for a long time. I'm also a physics enthusiast, and as some of you here might know, I ran something called the Detroit Physics Meetup back in 2014. And it was basically trying to get a group together of people who are interested in physics, who have some math background, to learn about physics, watching YouTube videos, exchanging information about books, things like that. And as a programmer, I would also write some simulation programs to help sort of understand the concepts. And so as part of that, one of the things I was doing was writing some simulation code for quantum mechanics. And specifically, maybe I should ask, I mean, are people here in science or programming? How many people are like into programming languages or things like that? One, okay. And what about just science, software, education, stuff like that? Okay, great. So I was trying to do this simulation and I was failing. I wrote some Python code and mathematically this stuff just wouldn't really work very well. And so I started searching around online and I found some code that was just sitting out there that did the same kind of simulation I was interested in. It was really old, it was DOS software, but I ran it in an emulator and it worked really great. And I found out that the code came from a book originally, an out-of-print book, so I went and grabbed the book. It was this book, and lo and behold, it had the actual simulation type of thing that I was trying to do on the cover of the book, which is really kind of ironic. So now I was intrigued, like, what's going on here? So when I got the book, to my amazement, it said, most people who try to code up something like this will find that it's numerically unstable for these reasons, and that's why I implemented it this way. And I was kind of floored. I'm like, wow, this is exactly what I needed to drive the concept home. And so then I got kind of interested, what are these books and who wrote them, okay? So, taking us back to the early 1990s, DOS was still the predominant language on PCs, and this language, Pascal, this was actually the first language class I had to take in school. Still have the book because I never throw anything away. Was still popular in some universities, and you had PCs available everywhere. But I think, and maybe people who are in education, because I'm not, can correct me, but it seemed to me that from some of the stuff that I've read that there was an emphasis on a more integrated curriculum at the time. People were taking programming courses, learning a little bit about programming, taking physics courses, learning a little bit about physics. It was coordinated such that you might have a programming assignment to learn something about physics. I don't know if that's still the way it is, but I kind of remember it being that way. So what happened? Basically, a group of 27 physicists that ended up being across the globe did a multi-year project. They created simulations for, CUP stands for Consortium for Upper Level Physics Simulation. And they created simulations specifically for physics instruction. And they ended up publishing 9 books. I have them all laid out here. They came with old school source code on floppy disk. This one doesn't have it, but anyone remember when they used to come like that, right? And the best part is that it had user and design documentation. The source code was in Pascal for DOS. And it had exercises if you want to try to do something else to extend it. You can change the code to do this, you can change the code to do that. And it was funded to the tune of, well, I found some of the NSF grant information. I think it was 3 years of NSF funding was something like $750,000 750,000 was the thing I saw, and then I saw additional funding from some pretty big corporations. So this was not a small effort. So they had, books that spanned all the areas of physics, and this is the list right here. They didn't all come out at exactly the same time, but they came out in succession between 1994 and 1995. And so what happened? Well, when I first started looking at this, there was still a website that was around, and it's kind of funny. It says it was, there you go, there's your 1990s Cups logo at the top, and if you get down to the bottom, created in 1995. And this was still as it was in 2015. I'm using the Internet Wayback Machine to pull it up because basically it went dark in 2015, finally. And this was hosted at George Mason University. And as you can see, it calls out these three people as the directors of the project. And of course the books are out of print. Thank goodness for the Internet Archive and the ability to kind of go back and do research with it, because actually I had seen that website when it was live, and then by the time I spun around and got back to this project, it was gone. So I at least knew where to start. So the first thing I did was, okay, this is good. I like this book. The simulations are great. I'm going to at least try to gather them all up and see what I can end up with. So I managed to get all the books via online sources, right? Amazon, used book stuff. Sometimes it says comes with disc. Sometimes it says doesn't come with disc. Sometimes it doesn't say, and you just buy it and you hope it comes with the disc. And the disc might not have good code on it. So I played the game, and I managed to get all of these. I actually got like a couple doubles in the process, but I got only 8 of 9 good discs this way. So I packed up and went to Ann Arbor in the U of M Engineering Library, where it said they had the 9th book, and there was a pretty good chance that the disc was still in it, I had hoped. So as I'm going in an engineering library, I'm watching them, check in and out books, and I'm kind of wondering if there's any kind of like magnetic scanning system that they have there, because I'm thinking, I'm going to get this book, and I'm going to run it through the scanner, and that's going to be it. That floppy disk is going to be dead. But I went up there, and it was really busy. There were a bunch of kids filling up the whole place, studying. It was quiet, in the library. And I had purchased one of these fine Chinese brand USB floppy drives just for the occasion. So I go and do my Indiana Jones and find the book and open it up, and sure enough, the disc is in there. It's still sealed, so I'm like, I'm breaking it open in the library. Set it all up and start copying the disc, and it's making the super loud grinding noise. Everybody's like, what's this old guy doing over here in the corner? So anyway, managed to back up. Yeah, I managed to back up the last disc, and I archived all of the install disk images, and then I created a new archive for myself based on the installation of all of them. You can install them all side by side. They use a common library, but they have a different version, a subtly different version of the library that was distributed on every disk, just because of the nature of the distribution system back then. So then a little while later, I got a little bit more serious. I decided to actually try to see if these developers were still around, and get a little bit more information about the project, just sheer curiosity, really. And there were 3 of these series editors, like I mentioned. One of them is now deceased, but I did get, I sent an email to, at that time I sent an email to all 3 of those guys, and I put my email and my phone number in there. And within 2 hours, I got a phone call from Robert Ehrlich there, and he was very enthusiastic that something's done with his stuff, because it's basically nobody's asked about it probably in decades. And he also sent me the contact information for Maria, as well as a guy named Jarek Tuzinski there, who was sort of the maintainer of the Common Cups library code back in the day. And so I thought that's a really good resource. Usually the guy who's in charge of the code is like, he probably still has all the good info. And the consensus, like I said, everybody that I spoke with, I actually contacted Jarek also, was happy to see something being done with cups. It turns out that Jarek had his own archive, and when he sent it to me to look at, it was actually identical to the one I'd reconstructed from all the other 9 books. So maybe I should have tried to talk to him sooner, but it wouldn't have been as good of a story. And then Jarek said, well, the best documentation is in this other book. And I'm like, what other book? What are you talking about? I was looking at all this stuff. There was a book, and it was about the cups system in general. And so he sent me some info. I said, is it Wiley Publishing? Because these are all Wiley Publishing. And he said, no, it's American Institute of Physics. Here's the ISBN number. And I went to go look it up, and that went absolutely nowhere, which I thought was really interesting. Usually if you have an ISBN number, you find out something. At least that's what I've been led to believe. So let me just talk for a second about the architecture of the code. As I said, there's a common library of this Pascal code. It's built on something called BGI, Borland Graphic Interface for DOS. If anybody remembers Borland Pascal, Borland Turbo Pascal, it was a very popular programming environment for DOS because it was really, it was the first time it had like an IDE, basically. You could get in there, you could organize all the code, you could see what you were doing, and it was pretty nice. People liked it. There was actually a really, eventually there was the Turbo C environment that kind of used the same GUI. A lot of people use that also, all before Windows, everything else. And the components are broken down by, kind of as you would expect. They had some GUI components because these applications have a GUI, even though they're DOS. They had a 2D plotting system, a 3D plotting system, and an equation parser. Which is, you can kind of think about this a little bit like a mini MATLAB environment type of thing, before people were sort of doing that, or maybe MATLAB for DOS was around back then, but and all the code came on all the disks, so you could just look at all this stuff, and it was meant to be played around with. Today I went and put it up on GitHub, because I was been trying to figure out what to do with this stuff, and at least now there's an archive in one place. I can see here. Information about the authors. What did I miss? Yeah, there's a cached picture of the GitHub thing. I don't have any information about licensing, and I'll talk about that in a little bit, about why that's somewhat complicated, as you might imagine. GitHub doesn't require that you be clear about your license in order to put stuff up on GitHub. So you can build it for DOS with Borland Pascal, and I've done that. You can run it in DOSBox on a native platform, which I'll show in a second. And due to kind of the latest and greatest technology in emulation, there's also projects that you may have heard of from the Internet Archive. They kind of, Jason Scott of the Internet Archive kind of championed this ability to run old software in a browser, DOS-based software, other kinds of software. And so, if I took the disk images and put them on the Internet Archive in the right place, you could click on them and run them in your browser. So, so let's see if I can give you an example. I have stuff from my other talk here, so. No, I don't need this. Let's just run DOSBox. So this is a DOS emulator for Windows. Boy. Yeah, this VGA thing is going to be a problem. Anybody ever notice projectors never have a high enough resolution for what you actually need them to do?
Not always, but
Almost always.
almost.
I'm hoping that I can scale this thing.
Isn't that part of Murphy's Law?
What's that,
What?
Murphy's
Is it
Law?
one of
Yeah,
Murphy's
this is
laws?
Murphy's Law in action right here. Okay, so, that's a killer. I wonder if I can make it go any higher. So, you get an idea. It creates, after the install disks are run, it creates different directories for the different books. So, for example, CUPS EM is the electromagnetics solver, or the electromagnetic book, or classical mechanics, or something like that. So, I'm going to see if I can get this to go smaller once I actually run one. So they all come with a menu-driven. You're only seeing half the menu. This is not good.
Browser.
This is actually running straight from DOSBox. I just don't know how to scale DOSBox appropriately.
DOSBox is on your machine.
Yeah. Well, I can show you this. I can click here and give you the demonstration of it running in a browser. So this is just one of the programs.
Oh, that's
Yeah, I didn't package all of them to run this way, so unfortunately there's going to be one that I can show you right now this way, and then I could probably.
Oh, that's real
There's
cool.
not very many people around here, but yeah. So this one's actually written by Jarek, the guy who later maintained the code. This is one of the earliest programs in the CUPS library, and this is meant to give you some idea of being able to visualize fields, both scalar fields and vector fields, and you know the GUI elements. You know, basically you've got menu pull downs, you've got hotkeys. It's pretty good. You also have mouse, and if you want to, you know, you've got forms, so you can go ahead, and this is where it uses an actual equation parser here, so you can actually, you know, type in what you want to see. You can build up all of your own stuff, and then under graphs, you can do things like probe around inside here and get numerical information off of these plots. I kind of want to show better demos. This is a vector plot, but it doesn't look great. Let's see. What can I do here? I was ready to show some of the other programs, and I don't know this one as well. I've built this one many times because it was the first one, and I thought it would be the easiest one to try to build. But you can pick different things that you want to see in the different windows, and then it'll go through and replot them. So this is a really simple system. And this also doesn't have, I don't think this has the 3D graphs. Yeah, I'm going to draw a blank on this. But you can put 3D plots that you can rotate in various windows. You can put vector plots, scalar plots, contours. I mean, it's pretty full featured in terms of a math package, surprisingly. I mean, as soon as I start clicking through this stuff, I'm like, wow, dare I say, pretty, maybe not polished, but pretty complete for a system that is that old.
So, yeah, I noticed that you're running this in local. Do you have anything like this already up?
I do. I have this same one as a test. I think the next step, really, and I'll talk about it, is I want to put these on the Internet Archive so you can run this stuff. I mean, I'll talk about that in a minute. But yeah, I'm trying to think if there's anything else here. I mean, you can change the colors, temp directory, you know. The other thing you can do is when you're running it in the regular DOS boxes, you know, it's a little sluggish, right? Obviously, you could do much more, and you could have much larger data sets, and you could have things run with much greater frame rates. Although there are some animation programs, I'm going to have to, yeah, I don't know if I can, got nothing else in here. What I may do is, there's not that many people here, I may spin this thing around and just let people play with this. I'm going to try and end early enough that we can run some of these things more interactively. Whoever wants to come up and check them out. In fact, I think that's probably the best thing, because I'm just going to have this problem.
Well, there's no other way to open question.
Yeah, I mean, I can show you planetary orbits, but it really doesn't do much good here. I'll do it at the end. That'll make more sense. Always something. Okay. So I have demos here, but I'm going to throw the demos at the end so that we can see them completely. So one of the questions that I have has to do with licensing, and the other question is, what could you do? So the first thing is just sort of imagining what could you do with this code base in the future. Does it make any sense? This is why I have past, present, future question mark. It turns out there's an open source compiler called Free Pascal, and a really, really nice IDE for it called Lazarus that I didn't know anything about until I started digging around. And it has modes that are backward compatible with Borland. I mean, you can compile things, but the question is what platform are you going to compile it to now? Because it's somewhat dependent on DOS. Most all of the DOS dependencies are in the CUPS library. So it would theoretically be possible to port it to a native platform if you wanted to run it in higher resolution under some other set of APIs. Or there's, for those of you who might be familiar with it, there's a library called SDL out there, which stands for Simple Direct Media Library. And that has a C interface, but it has bindings for Pascal. And if you go ahead and you were to basically port that code base from DOS to SDL, it would be able to run natively on any platform that's supported by SDL, which is pretty much everything, including a JavaScript compilation, which would let you put it back into a web browser if you wanted to, without DOS being in there. So there's, the wheels are turning a little bit. I'm like, well, it's kind of interesting. Probably don't have enough time to do any of this stuff myself, but so I did the archiving, right? I archived the disks, and I didn't put them on the Internet Archive yet, but I have to be archived. The DOS executables will just run, so anything that was made originally will run. The books are another issue because the code is nice, and there's a lot of good notes in there, but like I said, the meta information that's captured in these books is actually quite valuable. And of course I could scan the books. I don't have a book scanner, but I'd be willing to do it.
Based on the age, there might be PostScript files available.
Yeah, it's
PDF.
It's a good question. So the next thing I did actually is I contacted some of the original authors, not all of them, and I got essentially email permission from those guys to do whatever I want to with this stuff.
Did you ask them for PostScript files and things like that?
Well, I didn't get into the publishing details because I think some of that stuff was it was worked out with Wiley because they're the ones that actually published it. So I contacted Wiley. I was kind of trying to decide, do I do that or do I not do that? At first I got no answer. I waited. Let's see how this worked. I sent an email. I got an email back saying this is no longer the email. Please use this other email. Then I called the second email and it said it may be 21 business days. It said go to all these databases, find out reference to these things, and if you can't, then we might get back to you, but it will probably take 21 days, business days. So I waited around for the answer, and on day 22, I mailed them again, and surprisingly, I got an answer back, like in a day. And they were like, oh yeah, sorry that this slipped through the cracks, we'd like to help you. This was somebody from Wiley UK, actually, who got back to me. And they said, can you send us some more information about what you're planning to do? That was question number one. So then I'm like, okay, I basically decided I didn't have anything to lose. Let's just ask them for what's the best case scenario. I want to make all this stuff open source. I want the ability to republish, these books that are out of print. And they said, thank you very much, and we'll get back to you. And then, actually they didn't. And then I sent them another mail saying, hey, you asked me this question, and now you didn't answer. Nicer than that. And then they sent me an email saying, oh, we got your request, we're working on it, you should hear from us in a couple of days. And then I heard nothing. And this was about 2 months ago. So I don't know whether to poke at them with the stick again or not. I think I might, but in the meantime, I've got involved in some other projects. I thought about doing this talk. I've been playing around with, can this stuff actually run in emulators and whatever. So at this point, the best definition is it's abandonware. Now, as I have here, if you look at the disks and the programs and the source code, they're all copyright the original authors. So you may have a book like this that has the name of the 3 people who were the series editors, the names of the 3 people who did the book, and then their names it says copyright these guys in all the code. But then there's a README that says copyright Wiley. So, there's notices in there that say it's copyright by Wiley, and it's copyright, at least as far as the code goes, it's also copyrighted by the individuals. The individuals who are not deceased, chances are if I went and contacted all of them, they would probably say, I don't care, This was meant to be shared through academic means. So it's very unclear what were the original agreements between Wiley and these guys. Was there a time when they, when it's no longer, under one person's copyright or the other? And my feeling is Wiley probably would have to pay like a lawyer or something to get the answer to those questions, and I don't know if they're going to do that. So on the other hand, you know, if the developers say they have the copyright and it's okay with them, I don't know. I'm probably going to continue trying to contact all the original developers just to see what can happen, because I'm sure, at least for some of these books, I can probably contact all 4 or 3 authors of each book, and at least get some kind of notice from them.
Well, then
So-
at least you have, it appears you've taken proper channels. If
Yeah.
somebody decides to, then
Yeah.
I contacted copyright owners, and it's on them.
Yeah,
Right.
documented evidence of
Right.
intent, yeah.
So, but I think lastly, so we have this unfortunate situation where, you know, this stuff predated the open source movement, you know, not by very many years. And if that had been an option, you know, I feel that, like, you know, spiritually this is the predecessor, right? So I started asking myself a couple of questions, like why did this stuff not have legs? You know, why are we still not using some kind of code derived from this stuff now in physics curricula across the planet? Well, the first thing that happened was PCs started getting faster, and these programs started crashing when they ran them on DOS machines that were faster than the original ones that they had. Borland had a bug in their runtime, and as soon as you tried to run it, it would just crash immediately on startup. And Borland didn't fix it. It took people who were big fans of Borland to come up with patches for the Borland compiler. Actually, they started by patching the executables first, and then there were patches for the compiler if you bought the big compiler. And on the CUPS website, not in the books, but on the CUPS website that was defunct, they were saying, oh, if your stuff doesn't work, please use this patch program, patch your executables, and it'll work again for a little while. So I'm sure that you know, sort of scared some people who were actually trying to use this in their curriculum. And then of course DOS was aging out and Windows was coming around. And to top it all off, the Pascal programming language kind of went out of fashion. So you kind of have this perfect storm of obsolescence. The platform was never designed for longevity.
There's other factors too.
Well, I've got one more, right? I don't know at this point how much programming and physics is integrated. Programming has become so much of a specialty. I don't know, I'm not in school anymore, but
So-
I think that might be part of it.
Okay, so let me mention the factor.
Yep.
A lot of the software packages like Mathematica, there are other packages that are much lower cost than, you know, Canada, that type of thing. They actually have curriculum embedded in the software packages that they're selling.
Yeah.
So they have, like, you know, beginning college classes and advanced stuff in mathematics and physics and other fields embedded in those simulation software. So when they teach classes, a lot of these, they're using that software from maybe this company or that company or another company.
Right, right. And I mean, you know, but and I see that there are platforms that have lasted for a really long time when they build stuff on, most of them being, you know, proprietary platforms, seemingly. I did do a little bit more research. It turned out that there was a project that came before CUPS that's called Muppet, which is very interesting. It's this guy, Jack Wilson, started this. I don't think he was intending for it to grow into something quite this big, but the GUI and the 2D plotting code that ended up in CUPS came from the same lineage. And then here's something that is even more disheartening. And this is what I learned after doing a little bit more research. It comes back to Jarek's extra book. What is the deal with the extra book with the ISBN number that I have no idea what it's from? I found out that there is actually a company or a division that is called Physics Academic Software, PAS. And there's a joint venture between AIP, the American Institute of Physics, and the AAPT, which is the American Association of Physics Teachers, where they created their own publishing house. And CUPS, well, here, I can show you rather than tell you. So you go to this PAS website, which I finally found. This is still live now. It says, so sorry, we've ceased operations in 2011. Go to this other website. Here's some screenshots of programs that used to be available for our publishing house. And there's just, you know, tons of stuff here, and thank you very much. That's basically, we're closing the doors, but here's a bunch of screenshots.
Pictures of dead prostitutes.
Yeah, so,
Please check Padre Digital.
yeah, well, none of it's there either. So, but they are the ones that actually published this Cups book. And I'll show you the link. This is, again, through the Wayback Machine. This is the mystery book, okay? You can order now. Here's the ISBN number. It's only, a single copy for $100, high school site license, 10-copy lab pack for $400, whatever. Also, all these other utilities, Muppet utilities, this couple thing was a Windows package that came after that. This place sold all this software, and it seems like it's all gone. Like maybe it ended up on someone's shelves in some school, and then when Windows 3.0 became Windows 95 or whatever, it all goes in the garbage. So it's like we're doing this stuff over again, building the same kind of software, trying to learn the same kind of lessons, applying for the same kind of NSF grants, and it's a limited life cycle. Oh, by the way, so they published some stuff that was even fancier. It turns out the editor was this guy, John Risley, who passed away in 2013. And I was looking, his papers are available at North Carolina State University, and it says 67 linear feet. So some of this software might be in, the Raiders of the Lost Ark warehouse at NCSU. So I started to think that this is part of a bigger pattern, right? I mean, we wrote a bunch of DOS software, it all goes obsolete. We write a bunch of Windows software, it all goes obsolete. Anybody remember Java applets?
Yeah.
They run in your browser, except now the browsers don't let you run Java code that way anymore. There were tons of physics demonstrations in Java applets. I mean, that was a huge ecosystem at one time, and I think it's mostly gone. Now, JavaScript is the language in fashion, and a lot of the things are, run great in a browser. But this is where I kind of am wondering why there isn't more real open source. And it turns out that there is. I mean, this is stuff that I just started to tinker with. There's a guy, there's a whole website called Open Source Physics. Most of it is written in Java. It's an interesting and somewhat, I think, controversial decision, because I tend to think Java is a more complicated programming language than Pascal.
Yes.
And if you have to be a Java guru to tinker with this stuff, that's kind of a high barrier to entry in my opinion. But Wolfgang Christian is a guy who is associated most with this open source physics thing, and it turns out in the day. And he's one guy I haven't tried to contact yet. So I think if there's anybody to kind of BS about this stuff and see, what there is and what you can do, he's probably the guy to contact next. So I think that's mostly what I have, except I haven't done any demos, and we have about 15 minutes to do demos and questions. So maybe I'll spin the laptop around and we can do some demos up here for people who want to see it. They're actually really cool, and I can take questions.
Hey, one question. So I know there's all this software out there, mostly proprietary, and they have lots of examples of a lot of different things. How does that compare to the set of physics that you have here? And I know there's a lot of open source software out there that people have done, but it's all over the place.
It's all over the map, right? Yeah.
Well,
Nothing like this
not-
concerted effort, focused on education first.
It's all over the map, but it's also all over the place. So, there's all different types of lots of different things, but it's also everywhere.
Right.
Is there just creating some type of repository talking about all the stuff that's out there, or creating some type of library system would be an interesting task, because, when people write papers, they provide some software often, and they make it open for other people to use. And so I know there's a lot of very interesting things out there, but from a curriculum perspective, that's what you see the proprietary stuff being really good at. And plotting software, there's open package plotting software.
Oh yeah, I mean, plotting software has been
rewritten
rewritten every single time that the platform changes. I mean, I've worked on multiple versions of plotting packages just in the company that I worked for 15 years, you know. But
new plot, GNU.
Right.
That's been out there for a long time. Still going.
It just becomes interesting to think about it in terms of if you were going to build a platform for educational stuff, you know, with expertise from people, you know, these guys, for example, they pick the way that they do the colors, the way that they represent the vectors on the vector plots. You know, they did a lot of thinking about every single thing, the way they did it with a very limited environment that they had. And it's obvious when you look at it, the craftsmanship. And it's just, you know, it's interesting to me, and it makes me think about how could we do it better now with that kind of thing. Yeah, this is this open source physics, a paper about the repository, and you can see even this paper was written as they were making the transition from what they called Physlit physics, which is Java applets, to easy Java simulations, because physics aren't working anymore. It doesn't say that, but you know, it's kind of obvious. Yeah, and this is that website. You can do a lot of stuff with this. It's just it makes me wonder what's the life cycle of that stuff. You know.
So where's all this located? In the way back?
If you just go to open source physics, just Google that. This is what this thing is. So it's the stuff on the last slide. Let me I'm gonna, before we get too much further, I want to run some of these things, and I want you guys to be able to see it because it is pretty cool. I'm gonna unplug the projector. I think that's the only way I'm gonna get there. And we get like 4 times more resolution on the screen. So, unfortunately, it's also much smaller. But
No, it's in, I think it's in a cool down cycle.
So I'm just going to go into the classical mechanics stuff to start with. It's sort of the most obvious and easiest stuff. And it runs pretty well too. So they're doing planetary simulations from different reference frames. Let's put some back here. You can create your own. We got a lot of different systems here. Sun, Earth, Moon's kind of interesting. So they create different windows and do different kinds of plots in different windows. It's trying to figure out how to do. So this is the Sun, Earth, Moon system from different perspectives, from different viewpoints. Just as an example, I mean, obviously there's curriculum material that goes along with all of this. The function key thing gets a little tedious. But it was the way it was back then, you know. Coupled oscillators is kind of cool. Yeah, I mean, how many times, right? Yeah, I mean, you know, there's the plot of the energy transfer from, you know, one oscillator to the other. It's pretty neat that they built an entire programming environment where it was easy to do this kind of stuff, or at least, you know, some of this stuff's non-trivial. I mean, let me go into some of the more advanced stuff. This will be great when you can just click on the web and do this, but I haven't quite gotten there yet.
You say all of this was up on GitHub?
Yeah, I just put it there today.
Okay.
So, there's some interesting and weird things where you can create trajectories for charged particles, and it generates what the electromagnetic field would be like. I mean, you know, they're doing this in DOS with very small amounts of memory, and they have some solvers that do like field stuff, and it's pretty impressive.
Is that quarter second per frame?
Something like that, probably. I mean, the interesting thing is, here, let's see if I can run that again. Menu changes.
It's electromagnetic field or
here looks like.
Return to the default data. Okay, hang on a second.
What I want to show you is that right now I'm running this at the speed of a regular DOS machine, but you know, you can unthrottle the emulation so that it runs faster, you know, than a DOS machine normally would.
yeah.
You know, and just to give you some idea of what you could
You
do
can actually see the
with the current.
So it's just moving in a circle. Okay.
Yeah, it's just doing a circle because I think that's the trajectory that's pre-programmed. But I think you can change the trajectories. I want to do one of the quantum mechanics ones because it was the simulation that I had so much trouble with. Oh, that's not it. What do I want? I think it's doubling up my clicks because it sped it up so much. Let's slow it back down a bit. Yeah, so quantum mechanical time development. What this does is you have a wave function in 1D. So this is sort of a probability distribution of where there could be a particle. And then you can create different kinds of potential. So basically a first year quantum mechanics student might do some of these things, might do some solving of things by hand. But the time development stuff gets kind of hairy. And when you create, so this is in a flat distribution with like no energy. If I go ahead and run it, oh god, it's so slow. But we can fix that. So what generally happens is that as time goes on, you lose information about the position of the particle as the wave function spreads out, and so that's actually what's happening here. But depending on what kind of potential you put it in, if you put it into a harmonic oscillator, okay, and I think it's reset this run. There we go. You know, they're using colors for phase, which is another interesting choice. Like, they only had, 16 colors or something to deal with, and they didn't have another degree of freedom, so. But anyway, you do this thing, and it flattens out a little bit, but as it gets to the different barriers, it sort of reconstitutes itself, and the phase reverses, and then it bounces off the other barrier, which is what it's actually supposed to do, and it's supposed to do that indefinitely. Now, due to numerical ways in the solver, it does start to get distorted after a while. But again, if you don't use the little trick that they put in here, it'll go, things will go downhill fast. Simulation in particular. But these guys got it right, you know. They were working with stone knives and bear skins, but they did a pretty decent job. So you know, a little tricky to get back out of this, but you know, I'm hoping if I can get this stuff up on Internet Archive, then everybody will be able to click and play with them. You just won't be able to get the meta information that everyone's will soon till I get the wherewithal to scan them.
So where are you going to post the information so that other people can start using it? You know, like all the people in this room.
Yeah. So my GitHub address was there, and that's probably step one.
So why did this ever fall out of use?
Yeah, I mean, it's you know, I had that one slide which was all the reasons why I could think of why it did. There might be more. Yeah, that's where it is on GitHub. Thank you. And
Probably
and then
post your slideshow.
yeah, the intent originally was to get everything running in a browser, and I kind of fell short. This is the first time I tried this. This is Reveal.js, which is a presentation framework that uses JavaScript and HTML entirely. I started using Google Sheets. What's the one that's for PowerPoint? Google Slides. And I suddenly got the idea that, hey, if I can run the simulations in JavaScript and I can make a presentation in HTML, then maybe I could have this thing that I can just post and people can click on it, they can play with the programs, and they can run this thing. I just kind of ran out of time before I got there.
So, you know, two places they mentioned the Penguicon slides, so we can put it there. And then the other place that can be more of a community environment is the meetup. I don't know if you still have the meetup or not.
Yeah, I do.
You can post it there and, you know, invite everybody to
That's a good
sign
idea.
up for the meetup.
That's a
and
good
then
idea.
That's a real communication environment.
But I will put it at the Internet Archive, and when I do that, you'll just be able to search for cups on Internet Archive, and it'll just all come up over there. And then, through the miracle of the Jason Scott system, you'll be able to click on the things, and it'll just run in either Firefox or Chrome. So.
Meetup?
So the Detroit Physics Meetup, it's kind of defunct. It ran from 2014 to 2015 sometime, and then it kind of fizzled. And I'm still maintaining it. The next plan was to build a website based on the lessons learned from 1 year of running the meetup, and that kind of stalled out. And I haven't done anything with that since. I'd like to resurrect it at some point. I've just been too busy. So.
It just existed.
What's that?
I didn't know that existed.
No, and I haven't really been pushing it at all because it was every 2 weeks we would meet, and we'd probably get a half dozen people. When it was actually like a sort of study group, we'd be watching like Leonard Susskind lectures or something like that, and working out things. And then maybe we'd get a dozen to 15 or more people when we'd show a movie or do just more of a general audience lecture, which we did maybe every other month or something like that. My workplace was really good about it. They let us use our conference rooms, and so we did one at I3. We did one at I3, which was the when I did the electroharmonograph thing.
Okay.
That was actually a Detroit Physics meeting, but I basically talked about that project. So
This is what I would like to see. Kind of stuff I would like to see at Sunday Assembly.
yeah. Well, that'd be good.
Sunday Assembly is kind of turned upside down. So
Yeah.
he may be contacting you.
Just when I need
know,
another
it's that whole
project.
thing, right?
Oh, and if anyone wants to see what I've been doing with arcade game emulation stuff, I'm doing another talk tomorrow morning at 10 o'clock on the main arcade emulator being 20 years old. So, shout out to that one.
You didn't bring your museum this time?
I brought a lot of visual aids. So.